Good afternoon, sir.
Good afternoon. कति जना छ 12-11 जना मात्रै रहेछन् त 5 6 7 8 9 10 11 जना मात्रै कहाँ गए यिहरु कृतिका तिमसिना
हजुर सर
रेडी गर्यौ त स्लाइड अब ओके रचनाले रेडी गर्यौ
नो सर मलाई थाहै छैन के को भन्दिनु न
ल विनयले खोइ त विनय बोलेन
मैले त सर अस्ति क्लासमै प्रेजेन्टेसन गराएको त सर सुरु
ए तिम्रो सकिसक्यो विनयको विनय रिवेशहरुको सकिसक्यो यमुनाको यमुना
छैन सर
स्लाइड छ कि छैन
छैन आदिनाहरुले बनाएको थियो
के अरे
आदिनाहरुले बनाएको थियो पठाउनै पठाएन
अब कहिले पठाएर कहिले गर्नु त नि सधैँभरि प्रेजेन्टेसन नै हामी बसिरहनु कि फरवर्ड पनि बढ्नु सोनिका सक्यो
हजुर सर
स्लाइड बनाएको छैन स्लाइड बनाएको
सर फर्स्ट को बनाएको छु आधी चाहिँ बिन्साहरु बनाउँछु भने
फर्स्ट को कति बनाएको छौ
इनकरेक्सन सम्म
कहाँसम्म
इनकरेक्सन
सम्म बनाएको छ
हजुर सर
ओके कृतिकाले कहाँसम्म बनाएको छ कृतिका तिमसिनाले कहाँसम्म बनाएको छ
रियुरेन्स सम्म छ
कहाँसम्म
रियुरेन्स सम्म छ
रेजोनेन्स ट्युब सम्म दुई जनाको बराबर रहेछ स्वस्तिका माझी स्वस्तिकाले
आधी बाँकी छ बनाउन चाहिँ
कति बनाएको छौ
स्ट्रिङको चाहिँ बनाएको छ अरुको चाहिँ बाँकी छ
स्ट्रिङको बनाएको छौ
हजुर
ओके ल भेरी गुड त्यसो भए पुगिहाल्यो त स्ट्रिङको तिमीसँग छ सोनिका र कृतिकाले त्यसमा बनाएको छ त्यस पछाडि म टपिक त्यस पछाडि नयाँ टपिक पढाउँछु म ल यदि गरेपछि हाम्रो प्रेजेन्टेसन यस पछाडि क्लासमा हामी प्रेजेन्टेसन गर्दैनौँ अब लास्ट प्रेजेन्टेसन भनेकै तिमीहरुकै हो अब जतिले गरे नगर्ने गर्दैनन् अब के गर्नु त श्रीजा ढकाल श्रीजाले कति गरे सधैँ क्लासमा प्रेजेन्टेसन मात्रै गर्ने कुरा त भएन नि त श्रीजा गायब भइसक्यो क्या नाम लिँदा बित्तिकै टिएपी हानिसक्यो क्या ल प्रेजेन्ट गर नि त ल कृतिकाबाट सुरु गर ल यो लास्ट प्रेजेन्टेसन हो है त्यसपछि हामी नयाँ टपिकमा सुरु गर्छौँ कृतिका रेडी हो कता कृतिका
हजुर सर म गर्दैछु
ल कृतिका पछाडि सोनिका अनि स्वस्तिका है त
भयो सेयर
भइरहेछ राम्रो फोटो आइरहेछ एउटा मुसुक्क हाँसेको यो चाहिँ फोटो देखाउनलाई यदि यो गरेको क्या हो
होइन सर आयो
आइरहेछ भइरहेछ ल इङ्ग्लिसमा है
stationary wave in pipe to type
हुन्छ one is
इङ्ग्लिस
open
भनेको त्यही हो, टु टाइपमा हुन्छ भन्छ इङ्ग्लिसमा।
two type are there closed organ pipe र open organ pipe closed organ pipe closed organ pipe is a pipe which closed at one end and open at the another end is called closed pipe. Closed pipe को first mode of vibration figure यहाँ छ figure. In this mode there is one node and one antinode are formed in this pipe is called first mode of vibration. And length is lambda by 4 and velocity is equal to frequency into lambda. And F1 is equal to B by 4L. This is the fundamental frequency of first harmonic. And second mode of vibration, if two node and two antinode are formed in organ pipe, that is called second mode of vibration. If the length is L2 and wavelength is lambda 2, velocity of sound is equal to F2 is equal to 3 B by 4L, and B by 4L means F1 and F2 is equal to 3 F1. This is the third harmonic and first overtone. Third mode of vibration, if there is 3 node and 3 antinode formed in organ pipe, then it is called third mode of vibration. L is length of the pipe is 5 lambda by 4 and F3 is equal to 5 F1. This is the fifth harmonic and second overtone. Similarly, it can be shown in F4 is equal to 7 F1, F5 is equal to 9 F1, and there is only odd harmonic are present in the even harmonic are absent huncha. Open pipe is a pipe which is open at the both end. In first mode of vibration, if two antinodes and one nodes are formed in pipe, that is called first mode of vibration. F1 is equal to B by 12. This is the lowest possible in the given length of the open organ pipe, so it is called fundamental frequency. In second mode of vibration, if 3 antinodes and 2 nodes are formed in pipe, that is called second mode of vibration. And F2 is equal to 2 F1. This is the frequency present in second mode of vibration. This is also called second harmonic or first overtone. Third mode of vibration. So this similarly 4 antinode and 3 nodes are formed in this pipe. This is called third mode of vibration. And F3 is equal to 3 into F1. This is the frequency present in third mode of vibration and second overtone. In point of correction, in the above calculation, it is found that there is the E percent equal E चाहिँ त्यहाँनेरि in correction हुन्छ.
Finished?
Yes.
How fast? You move like a metro train so fast. Your speed is like a rocket. Just only read whatever you have written in your slide. Just you read only. After that, Sonika.
सर उसले नै सबै भनिसक्यो त नि.
Explain it again. फेरि सुरुबाटै गर्ने हो. उसले त पढेको हो कहाँ भनेको त. तिम्रो आफ्नो स्लाइड प्रेजेन्ट गर्ने हो. तिमीले नयाँ डिफरेन्ट भन्नुपर्ने भनेको हैन नि त. Just whatever you have prepared, just present it. After that, Swastika Maji will explain. सविता चौधरी सविताको केही छ सविता just slowly explain okay yes
Stationary waves in closed and open pipe. There are two types of pipe. Organ pipe. In organ pipe, there are two types of pipe. One is closed organ pipe and open organ pipe. An organ pipe whose end is open and another end is closed is called closed organ pipe. Figure are shown here. And in open organ pipe and organ pipe whose both ends are open is called open organ pipe. There are some terms. Overtone. Overtone is a term applied to any higher frequency standing wave. Harmonic. Harmonic represents the cases in which the frequencies of the overtones are integral multiple of the frequency of the fundamental. The fundamental frequency is called the first harmonic and 2F is known as the second harmonic and so on. Overtones or harmonics are also known as resonance. Stationary waves in a closed organ pipe. In this case of closed organ pipe, the closed end has to be mode while the open end must be an antinode. The various mode of vibration are indicated below. First mode of vibration. If one antinode and one node are formed in the pipe, it is derived as first mode of vibration. Here B is equals to F1 into lambda. F1 is equals to B by lambda. This is considered as equation 1. And we have length is equals to lambda by 4. Lambda is equals to 4, let equation 2. And from equation 1 and equation 2, we can write that F1 is equals to B by 4L. And the sound produced in this mode of vibration is called fundamental tone or first harmonic, and its frequency is called fundamental frequency. Similarly, second mode of vibration is also known as first overtone. If two antinodes and two nodes are formed in the pipe, it is derived as second mode of vibration. And here lambda 2 be the wavelength and f2 be the frequency of the sound produced in this mode. And here सर सुनिँदैछ
सुनिँदैछ
सुनिराखेको छ स्लाइड अलिक लार्जर बनाऊ जुम गर न के भयो तिम्रो सानो आइरहेको मोबाइलमा पनि यस्तो नहुनु पनि
Similarly, and second mode of vibration, here B is equals to F2 lambda 2 and F2 is equals to B by lambda 2. It is considered as equation 1 in second mode of vibration. And we have lambda 2 by 2 the frequency of vibration F2 is given by B is equals to lambda 2 into frequency 2, and here frequency 2 is equals to B by lambda 2, and we have that lambda is equals to 4L by 3, and B by 4L by 3 is also can be written by 3B by 4L, and we have let that in first mode of vibration B by 4L is F1. Similarly, in this B by 4L, B F1, and we can write that 3B by 4L is 3F1. And F2 frequency to second mode of vibration is considered as 3F1, 3 times of first mode of vibration. And third mode of vibration is also known as second overtone. सेकेन्ड मोड छुटेको रहेछ थर्ड मोड सर यहाँ लेख्न छुटेको रहेछ म भन्छु ल थर्ड मोडको चाहिँ
हुन्छ
Third mode of vibration is also known as second overtone. In this mode of vibration, there are 3 nodes and 3 antinodes within the pipe as shown in figure. This one, last one is the third mode of vibration figure. Here L is equals to 5 lambda 3 by 4 and lambda 3 is equals to 4L by 5. If F3 is the frequency of second overtone, then B is equals to lambda 3 F3. Here F3 is equals to B by lambda 3. B by lambda 3 is 4L by 5. And F into B by 4L. B by 4L also denoted by B1 from first mode of vibration. And here in third mode of vibration, 5 times of first mode of vibration is known as the third mode of vibration. And this is the frequency of the second overtone or fifth harmonic, which is 5 times the fundamental frequency. In this way, other higher mode of vibration can be obtained, that is F1 is equals to F1, 3F1, 5F1, 7F1, so on. Stationary waves in open organ. Same as closed organ pipe, here also it is there are 3 open organ pipe, 3 mode of open organ pipe, and first one is if 2 antinodes and 1 nodes are formed in the pipe, then it is called first mode of vibration. If L be the length of the pipe and lambda 1 be the wavelength of the pipe, then F1 be the frequency. And we have that B is equals to F1 lambda 1. F1 is equals to B by lambda 1. We have lambda 1 by 4 plus lambda 1 by 4 is equals to 1, because here is 2
नेक्स्ट खोइ त सकेपछि खोइ त थ्याङ्क यू भन्नु पर्यो त्यो सकेको इन्फर्मेसन दिनु पर्यो नि त वी आर वेटिङ फर योर नेक्स्ट स्लाइड स्वस्तिका स्वस्तिका हेलो स्वस्तिका
हजुर सर
तिम्रो स्लाइड छ हैन स्ट्रिङको
हजुर
ल स्ट्रिङ प्रेजेन्ट गर न अब त्यसपछि म थोरै अनि आजको नयाँ टपिक थोरै स्टार्ट गर्छु नि रेडी भएन
सर यो भएन सेयर नै भएन
के भयो शेयर भएन
हजुर
शेयरमा जाऊ के भएर भएन हुन त
गएको सर आयो
छैन भएको
सर हुँदैन के भएको
सबैको भइरहेको त जस्तै अफ गर अनि फेरि एकचोटि हेर न शेयरमा जाऊ शेयरबाट फेरि त्यो फोल्डरमा गएर हेर त लोजिनाको रेडी छ कि छैन लोजिना केही स्लाइडहरू लोजिना कुराकानी
कृतिकाले देखाएकैमा थियो
कृतिकाकै फाइल हो त्यो
हजुर सर
त्यही भयो नि हुन्छ तिमीले आफ्नो मात्रै एक्सप्लेन गर्ने हो
ए सर मैले नि इनकरेक्सनसम्म नि बनाएको थिएँ क्या त्यही हो मेरो
ठिक छ त त्यही भयो नि एक्सप्लेन गर्ने हो उसले पनि एक्सप्लेन गर त्यही स्लाइड तिमीले नि एक्सप्लेन गर्ने हो फेरि पहिले स्वस्तिका गरौँ स्वस्तिका भएन
सर भएन त के भएको
के भयो त हौ मैले नम्बर अफ स्टुडेन्ट्स 2 लो बिहानदेखि नै क्लासमा यति नै थियो कि यो क्लासमा मात्रै नम्बर अफ स्टुडेन्ट घटेको हो
यो क्लासमा मात्रै होला सर
अहिले मात्रै यिनीहरूले प्रेजेन्टेसन आज भनेर यिनीहरूले नम्बर अफ स्टुडेन्ट घटायो हो है कति थियो योभन्दा प्रिभियस क्लासमा कति थियो
खै अघि त 25 26 भयो जस्तो लाग्छ
25 26 थियो अहिले 11 छ कि स्वस्तिका भयो अहिले ठिक छ नेक्स्ट क्लासमा 5 जना भए पनि न्यू टपिक सुरु गरिदिइहाल्ने हो पछि क्लासमा अनि मैले बुझिनँ मलाई थिएन भनौँ भने भाटाले हान्छ अनि
सर स्क्रिनमा आयो कि आएन
किन ब्याक गयो फेरि
सर आएको छ कि छैन भनेर सोधेको
आइरहेको शेयर भइरहेको छ vibration string and overtone
velocity of transverse wave in the string when a string of mass per unit length, mu under the action of tension T is said to a transverse vibration. The velocity of the wave propagation through the string is given by V equals to under root T by mu, where T is the tension and mu is the mass per unit length. In such vibration of the string, the disturbance produced at one fixed in travels along the string and in such a and gets reflected back at the other end. Since the original wave and reflected wave have the same frequency and amplitude, they superimpose to produce stationary transverse wave. Uh, there are different modes of vibration in the strings. In first mode of vibration, the string vibration is in one segment. There are two nodes at fixed ends and antinode in between them. If lambda be the length of string and lambda not be the wavelength of wave in this mode of vibration, and b be the velocity of wave and f be the frequency of wave in this mode of vibration. And then the frequency of wave is given by f1 equals to 1 by sorry यहाँ अलिक मिस्टेक भएको रहेछ कि
तिम्रो हल्का जुम गर त्यसलाई मजाले हेर्नै पाएन
सब भयो
भइरहेछ
then f sorry यहाँ कति मिस्टेक रहेछ कि then f1 equals to the b by 2l and f1 equals to 1 by 2l times under root t by mu. This is the fundamental frequency of first harmonic. It is also called the fundamental tones. And in second mode of vibration, there is two segments. Thus, there are three nodes and two antinodes between of strings, and L1 be the length of the wavelength of the string of wave. In this mode of vibration, L is equal to the lambda 1. If V be the velocity of wave and F1 be the frequency of wave in this mode of vibration, F1 equals to the B by lambda. Then the frequency is two times of fundamental frequency. This is the second mode of vibration, which is called the first overtone or second harmonics. In third mode of vibration, there are four nodes and three antinodes. So length is equal to the 3 lambda times sorry मिस्टेक भएको रहेछ कि पुरै लेख्नलाई and similarly in third mode of vibration, the frequency is 3 times of fundamental vibration. This is the frequency of which is called the second overtone or the third harmonics. In this way, all the harmonics, all the numbers are present, all the harmonics are present. So it is the sonorous and very pleasant to hear. There are different types of laws of transverse waves of strings. The velocity of transverse wave vibrating in a string is given by V equals to the under root T by mu, where the T is equal to the tension of string and mu equals to the mass per unit length. and f is equal to the 1 by the 2 L times under root t by mu. And there are the three laws of strings to the law of length, law of tension, and law of mass. The law of length fundamental frequency is inversely proportional to the resulting length of the string, and similarly, according to the law of tension, the fundamental frequency is proportional. Frequency is proportional to the square root of the string force or the tension. And according to the law of mass or the third law, the fundamental frequency is inversely proportional to the square root of the mass per unit length. And there is experimental verification of the laws of transverse vibration.
Okay,
We
not necessary to this experimental verification.
To verify the first law or the law of length. For the verification of first law, we take a tuning fork of non-frequency hanging a load of 0.5 kg on one end of string. Now to find the resulting of the wire between the bridges C and D, we placed a small paper placed on the wire and noted
Swastika?
the
Okay, not necessary this one. Your experimental verification for then Allah. Sakyo
Sorry,
Sakyo? Okay, thank you, Swastika. Good one. La. स्टप गर त म सबैले कपी निकाल ल एउटा दुईटा क्वेशन गरौँ ल अब all of you write the question उले यति हामीले प्रेजेन्टेसन गर्यो लेट्स ट्राई सम क्वेशन्स ल लेख त यो कसले मिलाउँछ है त a string is divided into 3 segments so that the segments, what is it, fundamental frequencies in the ratio 2:3. Then the length of the segments are in the ratio कति हुन्छ होला A मा your option A is 6:3:2 B मा 4:3:2 4:3:2 C मा 4:2:1 D मा 3:2:1 लु गर त कसले मिलाउँदो रहेछ यो तिमीलाई नै गराएको थिएँ मैले सिल्भरले तिमीलाई गराएको थिएँ नि क्वेशन
सर यो गराएको थिए त
गराएको थिएँ तिमीलाई गराएको
ए नम्बरको हुन्छ
तिमीहरूलाई गराएको थिएँ कि कसलाई गराएको थिएँ 6:3:2 है ओके त्यसो भए ए म कसलाई तिमीलाई गराएको थिएँ सिल्भरलाई गराएको थिएँ ल यो गराइसकेको छ भने ल गराएकोले भइहाल्यो जसले गराएको थियो नगरेकोले यो गर ल in a closed organ pipe the fundamental fundamental frequency is F. What will be the ratio? What will be the ratio of the frequency? What will be the ratio of the frequencies of the next 3 overtones? A ma'am. 2:3:4. B ma'am. 3:4:5. C ma'am. 3:7. 3:7:11. D ma'am. 3:5:7. 3:5:7. Look, another. Next try the one. Closed organ pipe mai. कसको रेशियो हेर भन त कसको रेशियो हेर त
Sir, 357 हुन्छ
हेर है हामीले के छ क्लोज organ pipe मा closed organ pipe को कुरा है चाहिँ है क्लोज organ pipe कसले एक्सप्लेन गर्थे कृतिकाले हैन कृतिका
सर
क्लोज organ pipe मा पोसिबल फ्रिक्वेन्सीहरु के हुन् भन त व्हाट आर द पोसिबल फ्रिक्वेन्सीहरु f अनि नेक्स्ट फ्रिक्वेन्सी कति कति कृतिकाले भने f2 भने कति हो त कति टाइम्स अफ फन्डा
3f1
हो त्यही भने 3f अनि
5f1
5f अनि
7f1
7f अनि 9f गुड हो यो सबैलाई थाहा छ नि हैन हामीलाई कसको रेशियो हेर्नु छ र त रेशियो अफ द फ्रिक्वेन्सी अफ कसको नेक्स्ट 3 ओभरटोन्स कुन फ्रिक्वेन्सी पछाडीको f पछाडीको
फन्डामेन्टल
यो f पछाडीको भनेको चाहिँ f पछाडीको भनेको f भन्दा ठुलो अरु तीनटा ओभरटोनहरु यो के हो त यो फर्स्ट ओभरटोन यो के हो सेकेन्ड ओभरटोन यो थर्ड ओभरटोन हेर त रेशियो कति हुने भयो
3:357
5:5 के हुने भयो 7 हुने भयो कि हैन 3:5:7 भयो भएन भयो
सर
ल अर्को है त the fundamental note notes produced in an open and close end pipe of the same length are in the ratio A ma'am 2:1 1:2 B ma'am 2:1 C ma'am 3:4 D ma'am 4:3 Try this.
Sir, 2:1.
निकाल है कति आउँछ
1:2.
Sir, 1:2.
1:2. 2. कसरी निकाले 1:2? शेयर गरेर देखाऊ हामीले के निकाल्दा फन्डामेन्टल नोट प्रोडक्सन ओपन इन द रेशियो फन्डामेन्टल फ्रिक्वेन्सी को रेशियो निकाल्नु पर्ने हो कि हैन f1 by केमा क्लोज्ड र सरी ओपन र केमा क्लोज्ड मा हो के हैन
हो सर
भनेपछि दुईटैको स्ट्रिङको के छ
Same length.
दुईटै यही ट्युब हो ओपन हुँदाखेरि कति हुन्छ यसको फन्डामेन्टल फ्रिक्वेन्सी लु भन त जति बेला यो
B/12
क्लोज्ड हुँदाखेरि एउटा भयो ओपन हुँदाखेरि यो भयो क्लोज हुँदाखेरि दुईटैको लेन्थ सेम छ f इक्वल टु कति हुन्छ v बाइ कति हुन्छ
12
यो भयो क्लोज्डमा ओपनमा कति हुन्छ v बाइ 12 अब गरौँ त ल ओपनमा v बाइ 12 डिवाइड बाइ क्लोज्डमा v बाइ 12 हैन यो भनेको v बाइ 12 इन्टु उल्टो हुन्छ नि यो त हैन 12 बाइ v कति आउने हो एरर काटिन्छ भिभी काटिन्छ कति बाँकी रहेछ
2/1
2/1 अनि कसरी 1:2 आयो त 2/1 आयो भन्दा 2:1 पो भयो त्यो त
तर त्यहाँ क्वेशनमा चाहिँ ओपन र क्लोज लेख्नु भएको छ नि त
ह अनि ओपन र क्लोज त छ नि ओपन र क्लोज त छ नि फ्रिक्वेन्सी अफ द ओपन एन्ड क्लोज एन्ड भएन र
2/1 हो
क्लोज टु ओपन भयो भने चाहिँ त्यो हुन्छ होला के भयो भने त
ठीक छ सर
भाइ भएन के भयो के भन्दैनौ त
भयो सर
भाइ के रहेछ 1:2 आउनेको के भयो
सर त्यो भिभी डाइरेक्ट काटेर अनि
भिभी डाइरेक्ट काटेर अनि के भयो त
अनि 1:2 आयो भन्दै छ नि
भी काट्यो अनि लेन्थ पनि काट्यो अनि
2 and 2 अनि 2 to the 4
यो 2 गरेर यहाँ 1 बाँकी रह्यो यो त 1/2 बाँकी रह्यो यहाँ 1 बाँकी रह्यो हो यहाँ के बाँकी रह्यो यहाँ त 1/2 बाँकी रह्यो यो मेन लाइन भयो वेभ टु द माथि माथि गइहाल्छ त यो डिनोमिनेटर यो न्युमिनेटर हो यहाँ पनि 1:2 कहाँ भयो त नि भयो त भयो कि भएन भएन है
भएन सर भएन
if F1 is the resonance frequency of a pipe open at both ends and F to be the resonance frequency of a pipe open at one end only and both are vibrating in the fundamental mode and the pipe are of same length then then A F1 equals to 2F2 B F1 equals to F2 C 2F1 equals to 2F1 equals to F2 D 3F1 equals to 4F2 के हुन्छ लु भन्नु ल के हुन्छ ल भन
F1 equals to 2F2.
F1 equals to
2F2.
2F2 हो ओके न
हो सर
सबैलाई भयो F1 equal to 2F2 हो यहाँ र यो क्वेशनको एन्सर त यही माथिबाट आउँछ यहाँबाटै यहाँ हेर दाइ यहाँ भर्खर हेर F1 भने कसको फ्रिक्वेन्सी हो ओपन पाइपको हो कि हैन हो भनेको त F ओपन हो नि F1 भनेको त के हो त F1 भनेकै फ्रिक्वेन्सी अफ द ओपन पाइपको हो कि हैन नि के भनेको छ F2 with the resonance frequency of के pipe open at only one end भनेपछि F2 भनेको कसको रहेछ क्लोज्ड पाइपको यहाँबाट भर्खर हामीले के निकालेको थियो त फ्रिक्वेन्सी अफ ओपन टु द फ्रिक्वेन्सी अफ क्लोज्ड भनेको कति निकाल्यो हामीले 2/1 हैन यहाँबाट के लेख्न पाइयो फ्रिक्वेन्सी अफ open organ pipe is के हुन्छ twice of
2 times of
frequency of closed organ pipe कति बेला यदि दुईटैको लेन्थ के छ भने सेम छ भने दुईटैले के गर्नु पर्यो फन्डामेन्टल फ्रिक्वेन्सी नै फन्डामेन्टल फ्रिक्वेन्सी नै त्यसले मोड हुनु पर्यो अब फ्रिक्वेन्सी अफ ओपन भनेको हाम्रो के त F1 इक्वल टु कति भयो त 2 F2 भयो F1 equals to F2 भयो भएन
भयो सर
ल सबैलाई भयो
सर
आजलाई यति अब नेक्स्ट क्लासमा हामी न्यू टपिक अकोस्टिक फेनोमेना भन्ने टपिक पढ्छौँ है बुझ्यौ नि सबैले अब प्रेजेन्टेसन सबै कतिको बाँकी र सक्यो
हुन्छ सर
नेक्स्ट क्लासमा हामी के पढ्छौँ अरे acoustic
Phenomena.
phenomenon. This was for today. Bye class. Thank you, everyone.
Thank you, sir.
Thank you, sir.